So first, when I'm solving a trig equation, what I want to do is I want to make sure I'm reading the directions of how my answer should look. So in this case, it's telling me that the theta, which is my variable in both these situations, needs to be at least 0 and less than 2 pi radians. So 2 pi cannot be a solution. 0 could be a solution, and I'm not going to add 2 pi n because I'm not going around and around the circle. I'm just going one time around the unit circle. So my strategy is when I write these, I want to write an x for the trig expression. So in doing that, it just makes it easier to solve for x, or don't be intimidated by having that tangent. So then I'm going to divide both sides by negative 12, and I'm going to end up with x equals, this would reduce, root 3 over 3. So it's negative root 3 over 3. So now I'm going to put my tangent of theta back in for x. So it's going to be negative root 3 over 3 equals tangent of theta. So what we're doing is we're trying to figure out what values of angle measures in radians will give me a tangent of that angle equal to negative root 3 over 3. So if you recall, I'm going to go back here. I'm going to make a chart of sine, cosine, and tangent. So 30, 45, I think this is good to know to be able to make up this chart. So I have sine of theta, cosine of theta, and tangent of theta. So the sine of 30 degrees is 1/2. The sine of 45 degrees is root 2 over 2, and this is root 3 over 2. Cosine is going to be root 3 over 2, root 2 over 2, and 1/2. And the tangent is going to be sine divided by cosine. Okay, tangent is the sine of theta, which is the y, divided by the cosine of theta, which is the x. So if I divide 1/2 divided by root 3 over 2, I get 1 over root 3. We can rationalize this to get root 3 over 3. If I divide these, it's going to be 1, and if I divide these, it's going to be root 3. So it's kind of crucial that I would try to make this chart, have it down. Know that the tangent of 30 is root 3 over 3, and the tangent of 60 is root 3, and the 45 is 1. So it's important to know that. So let's go back to this one. We have root 3 over 3, and it's negative. So we know that it's going to be some type of 30-degree angle, but it's going to be negative 30. So it's important to know that in your 4 quadrants, tangent is, x is positive, y is positive in this quadrant. X is negative, y is positive in the second quadrant. X is negative and y is negative in the third quadrant. And x is positive and y is negative in the fourth quadrant. So we're looking at where tangent is negative. So tangent is y divided by x. So tangent is negative in the second quadrant and the fourth quadrant, and it's positive in these 2 quadrants. So if I have negative root 3 over 3, I'm actually having, it's a 30-degree angle. So I have to make a 30-degree angle that is perpendicular to the x-axis. So it's this angle right here. So this angle is 150 degrees. I also have to make a 30-degree angle in the fourth quadrant and have this right angle be perpendicular to the x-axis again. So this angle is going to be 330 degrees. So I have to go back and look at my interval. Well, the directions read that I needed between 0 and 2 pi. So I'm going to have to answer in radians. So to convert to radians, you need to multiply it by pi over 180. So both of them multiplied by pi over 180. So your two solutions are going to be 5 pi over 6 and 11 pi over 6. That was a complicated one. So I'm going to walk more. Let's do this one. So this is going to be 3x. So I'm going to use that solution or technique to substitute in for x equals 4x. And I'm going to get one side equal to 0. So I'll get 0 equals x. So if I substitute sine of theta back in for x, I'll have sine of theta equals 0. So this is asking me, where is y on the unit circle? Because y is sine. Where is the y value 0? So 0 right here, 0 right here. So in degrees, that would be 0 degrees, 180 degrees, 360 degrees. But you have just restricted it to not include 2 pi. So you remember that in our directions, we couldn't include 2 pi. So that means that my solutions are going to be 0, 0, and pi in radians. Okay, in this case, our directions are all degrees. So all degrees would be if your angle was right here, then another angle would be that angle plus or minus 360 degrees n. Okay, it's because you could go clockwise or counterclockwise around 360 to make it. So what I'm going to do is I'm going to have the same strategy here, is I'm going to substitute in x for tangent, and I'm going to solve for x. So if I solve for x, I'm going to subtract 1 from each side. This would cancel out. So I'm going to have x equals negative root 3. And now I'm going to substitute back in tangent of x equals negative root 3. So again, know that chart, that tangent of 60 is root 3, and tangent is negative in the second and fourth quadrants. So I'm going to create a 60-degree angle and make it perpendicular with the x-axis. Another 60-degree angle, make it perpendicular to the x-axis. And this time I'm answering degrees, so I need to figure out what both of these degrees are. So the first one is going to be 180 degrees minus 60, so that's 120 degrees. The second one's going to be 300 degrees. But I need to answer in all degrees, so I'm going to do plus or minus 360 degrees n, and then plus or minus 360 degrees n. Okay, number 2. I'm going to do my strategy of substituting the cosine of x, writing an x, solve for x, and then substituting cosine of x equals 1/2. So what angles will give you a cosine that's 1/2? So if I look at my unit circle, where is the x going to be positive? That's what it's asking. So x is positive in the first and fourth quadrants. And the cosine is 1/2. Well, actually, the cosine of a 60-degree angle is 1/2. But I have to have a 60-degree angle in the first and fourth quadrant. So my answer is going to be 60 degrees. And then also 300 degrees. But I want all degrees, so I have to add on this plus or minus 360 degrees n. So just looking back on it, you need to know that in the first quadrant, cosine and sine are positive, and tangent. All of them are. So sometimes we use this mnemonic device. All seniors take computers or calculus, whatever you want to write. So in the first quadrant, all of them are positive. So cosine is positive, sine is positive, and tangent is positive. In the second quadrant, only the sine is positive. The cosine is negative, the sine is positive, and because tangent is sine over cosine or y over x, the tangent is going to be negative. The T stands for only tangent is positive. So it's cosine is negative, the sine is negative, Tangent is sine divided by cosine, so tangent is positive. And then the fourth quadrant, only the cosine is positive. So the cosine is positive, the sine is negative, and the tangent is negative. Okay, so in these two quadrants, the tangent's negative. In these two quadrants, the tangent's positive. These two quadrants, the sine is positive. These two quadrants, the cosine's positive.